Hi everybody, this is Algebra 2, Lesson 44, and this lesson is about solving right triangles. So we're going to be using those trig functions that we learned to actually solve some problems. So first off, sines, cosines, and tangents are ratios and are always the same for any given angle. So the ratio is dependent on the angle. The ratio depends only on the size of the angle and not the size of the triangle. We can use them to find missing parts of a right triangle. Alright, so 44.1 says, find the missing parts of this triangle. So we're going to zoom in here and look at this triangle. And first thing we're going to do is we're going to label this. So there is our angle, and it is 24 degrees. So the hypotenuse is going to be across from the right angle. So this is our hypotenuse right here. And then across from the angle that we're looking at is going to be our opposite. So y would be our opposite. So our opposite is y. And then this one would be our adjacent. Alright, so if we remember SOHCAHTOA, so ka and toa, that means our sine of 24 degrees is going to be equal to our opposite over our hypotenuse. Our opposite is y, and our hypotenuse is h. We can't really solve that because we need to have one variable, not two. Alright, so our cosine of 24 degrees is equal to adjacent over hypotenuse. So our adjacent is 9.5 over our hypotenuse, which is h. And then our tangent of 24 degrees is equal to opposite over adjacent, which would be y over 9.5. Alright, so we can use these to solve for y or h right here for our cosine and our tangent. Alright, to solve for b is actually really easy because we know that we have 90 degrees right here and 24 degrees right there. So 180 minus 90 would be another 90. And we're going to subtract our 24 because all of the angles have to equal 180. And so that would be 66 degrees. So we've got B right off the bat. B equals 66 degrees. Alright, so we're going to go over to our calculator and we're going to try to solve for our cosine first. So we've got cosine 24 degrees equals 9.5 over h. Now to solve for this, it's a little different than things that we usually solve for. If I multiply both sides times h, these are going to cancel out and I'm going to have h times the cosine of 24 degrees equals 9.5, and then I would need to divide by the cosine of 24 degrees on both sides. So that means these are going to cancel. So h is going to equal 9.5 divided by the cosine of 24 degrees. Alright, so I'm going to go over to my calculator. And I need 9.5 divided by the cosine of 24. So I need 9.5 divided by cosine 24. I'm going to keep that in parentheses there. I want to make sure that I'm doing 9.5 divided by the cosine of 24. And if I look up here, I can see that Yep, that is what I need. And that is 10.399, and we're going to round that to 10.40. All right, so that tells us that H equals 10.4. All right, we can also, the book tells us to estimate first. So if this is 9, that means that this is 9.5 down here, this adjacent one. That means that this one has to be somewhere between like 10 and, let's say 12. 10 to 12, or 10 to 12, somewhere in between there. And this one's probably going to be between 3 and 5, something like that. That way if we get a crazy answer, we know that it's not right. But we got 10.4, and that seems about right. Okay, so now we can use this tangent down here to find y. So we're going to use that one to solve for y. So we would multiply times 9.5 on both sides. So basically we're multiplying times 9.5. These cancel. And we're going to get 9.5 times tan 24 equals y. So we'll just go over to our calculator and do that. So we need 9.5, wait, clear all that. 9.5 times tan 24. 9.5 times the tangent of 24. And it is 4.229, so 4.23. So y equals 4.23. And there is the answer to that. All right, so we're using those trig functions that we learned to solve problems. All right, let's try another one. Find the missing parts of this triangle. All right, so first thing we're going to do is label. All right, so if this is our angle, 35 degrees right here, our hypotenuse is right here, our opposite is over here, and our adjacent's here. Okay, and we remember SOHCAHTOA. All right, so our sine of 35 degrees is going to equal opposite over hypotenuse. Opposite is x. Let me erase that. Okay, so our opposite would be x, and our hypotenuse is 14. All right, cosine of 35 degrees is going to be adjacent, which is m, over hypotenuse, which is 14. And the tangent of 35 degrees equals, forgot the equal signs there, equals, tan is opposite over adjacent, which would be x over m. All right, this one right here is not useful. We don't need that because we got two variables. These two we can use. All right, so we'll start with sine of 35 degrees. All right, so the sine 35 degrees equals x over 14. If we multiply both sides times 14, these will cancel, and we'll get 14 times the sine of 35 equals x. So we're going to go to our scientific calculator, and we're going to say 14 times sine 35 degrees. Let's make sure that's right. 14 times sine 35 degrees. And we get 8.03. Now, let's look at our estimate here. If we know that this one's 14, this one's got to be less than 14. It's probably around, it's more than half of that, so it's between 7 and 14. And this one is probably between, it's a little smaller than that, so let's say it's between like 5 and 8, somewhere in there. Alright, so those are our estimates. And what did we get? We got 8.03 for x. And that's going to be this one. Yep, 5 and 8. Yep, so this one is 8.03. So we'll put our answers over here. X equals 8.03. Alright, let's work on cosine. So cosine of 35 degrees equals m over 14. Okay, so I'm just going to multiply times 14 on both sides. Those cancel. So I need the cosine of 35 degrees times 14. So I could say cosine 35 degrees times 14. And I get 11.47 when I round that up. So that would be 11.47, and that's right in that range there. I don't need those anymore, so m equals 11.47. Alright, and we still didn't figure out b right here, this angle. We know that all of the angles equal 180. There's 90, so these two together have to equal 90. So 90 minus 35 is 55. I'm going to double check all this, make sure I got it right, but it looks right. So these are not difficult. You're just typing stuff into a calculator, but it's important to know what you're typing and have that estimate so that you aren't way off. Like if you are way off, then you'll know that you got it wrong. If let's say that if m was more than 14, obviously that would be wrong. If m came out to be like 2, obviously that would be wrong. Alright, and then we're going to try another one. Find the missing parts of this triangle. Alright, this one's a little more difficult because it doesn't give us either of these angles. We only know this 90-degree angle. So we have to try to figure out the angle. Now, we know that we can use Pythagorean theorem to find x. So we can say a squared plus b squared equals c squared. C is our hypotenuse, so that's going to be 7. And then we'll say a is 6. And then that b is going to be x. So 6 times 6 is 36 plus x squared equals 7 times 7 is 49. So we're going to say minus 36 on both sides. We're going to get x squared equals 9 minus 6 is 3. 4 minus 3 is 1. And then we just square root those. So x equals the square root of 13. All right, so that's equal to the square root of 13. So that's x. We need a, b, and x. Okay, so we've got that one. And then to find one of these angles, we can do SOHCAHTOA. So S-O-A, C, wait, S-O-H. Let me erase that. Back to my pen. SOHCAHTOA. Okay, so if we're going with angle A, we're going to say our hypotenuse is here. And this will be our adjacent. And this will be our opposite. So we're just going to try to find angle A or angle B. Alright, so this one, sine would be opposite, which we don't know, over hypotenuse, which is 7. Cosine would be adjacent, which is 6, over hypotenuse, which is 7. Okay, so we can figure it out now. It's 6 divided by 7 is our cosine. So we're going to go on here and we're going to say 6 divided by 7, 8.57, blah, blah, blah. But we need the inverse of that. So that is the cosine. So we need the inverse cosine. And that's 31 degrees. So that tells us that it's 31 degrees. If we want to round to that decimal point there, yeah, it would be 31 degrees. So A equals 31 degrees. Alright, now to find B, we're just going to say 90 and 31 from 180. So here's our 90. That means A and B added together have to equal 90. So we're going to say 90 minus 31. And we're going to get 59. So A equals 31 and B equals 59. They've got 31 in the book. They've got 31.01 and they've got 58.99. But if you came up with these answers, I would be happy with that. That's perfectly fine with me. Alright, so that's how you use trig functions to find missing parts when you have missing angles. Alright, so pause the video and work the practice problems, and then I'll work them for you. Alright, so this says use trigonomic functions to find the missing parts of these triangles. Here's A, and here's our triangle, and we're going to figure out what our missing parts are. So, first thing we're going to do is label some stuff here. So, here is our angle. It's 21 degrees. The opposite of that will be over here. The adjacent would be here. And this one's our hypotenuse. And we have H and Y, so we got to find the hypotenuse and the adjacent. And so we're going to start with SOHCAHTOA. Okay, so our sine of 21 is going to be equal to our opposite, which is Y, over our hypotenuse, which is H. That one's not going to help us. Our cosine of 21 is going to be equal to our adjacent, which is 6.4, over our hypotenuse. That one we can use. And then our tangent of 21 is going to be our opposite, which is y, over our adjacent, which is 6.4. Okay, so we can use both of these. All right, so we'll do this cosine one first. All right, so cosine of 21 equals 6.4 over h. All right, so I'm going to multiply both sides times h. Okay, and I'm going to get h times the cosine of 21 equals 6.4. Now I need to divide by the cosine of 21. And I'm going to get h equals 6.4 divided by the cosine of 21. So I'm going to go to my calculator and clear that, and I need 6.4 divided by the cosine of 21. And that equals 6.855, so 6.86. Oops. Now let's see. Does that seem about right? If this is 6.4, the hypotenuse, yeah, that could be 6.86. Alright, so our h equals 6.86, and that's actually the correct answer. And then we're going to do the tangent, so tan 21 equals y over 6.4. So I'm just going to multiply times 6.4 on both sides. So I need 6.4 times the tangent of 21. Let's cancel. So I'm going to come over here and say 6.4 times tangent 21. Whoops. 1, there we go. And I get 2.4567, which really rounds up to 2.46. So y equals 2.46. Alright, and that's our answer. We don't have any angles we have to look for or anything like that. That's the answer, h and y. Alright, that was A. Now we're going to do B. Alright, so for B, we've got two unknown angles and a missing side. Alright, so we're going to do, let's try to solve for x first. So we're going to say the adjacent would be down here. Our hypotenuse is here, because this is our right angle right there. I forgot to mark that. And then our opposite would be here. Alright, so ka, toa, our sine of x would be opposite over hypotenuse. Opposite will be 12. Our hypotenuse is p. That's not going to do us any good. Cosine would be adjacent over hypotenuse. Adjacent is 8. Our hypotenuse is p. That won't do us any good. Our tangent is going to be opposite over adjacent. That's what we need. Opposite is 12. Our adjacent is 8. Alright, so I just have to divide that up. So I'm going to say 12 divided by 8, and it's 1.5. No, that can't be right. Hang on, let's see. It's going to be x. Oh, the tangent of x equals 1.5, and we got to figure out what the angle is. So if our tangent is 1.5, then we need the opposite. We need a tan, and that's 56.31. So we got to round it up, 56.31. So x equals 56.31. All right, so if x equals 56.31, we know x plus y has to be 90. So we can say 90 minus 56.31. I'm going to do that on my calculator. 90 minus 56.31 equals 33.69. So that means y equals 33.69. Alright, and now we just have to find p right here. So we're going to have to use Pythagorean theorem. So we're going to say 8 squared plus 12 squared equals p squared. 8 times 8 is 64. 12 times 12 is 144 equals p squared. We're going to add these up. So 64 be 8. 64 is 10. 208 equals p squared. Alright, so that means that p equals the square root of 208. And we can break that down into, let's see, I think that's divisible by 16. 08. It's definitely divisible by 4. Whoops. 13 times 16, so oops. Square root of 13, square root of 16, square root of 16 is 4. So P equals 4 times the square root of 13. If you left it as this, I'm not sure, I don't know if I'd count that wrong. Try to break it down if you can. So if you just said, okay, 208 divided by 4, 4 times 5 is 20, and then 2, let's see, 4 times, let's see, divided by 4, 208 divided by 4, you're going to get 52. So that would be square root of 4, square root of 52, and then you'd say, all right, that's 2 times square root of 52, and then you'd have to divide that by 4 times 13, and then you could pull that out and say times 2, and you'd end up with 4 times square root of 13. Either way, try to break it down to the lowest form that you can. But anyway, this is the answer right there. So hopefully that wasn't too confusing. I think that was all we had for practice. Yep. So that's it for that lesson. And so we're just using what we learned about trigonomic functions to solve right triangles. So that's it for lesson 44.